Welcome to section 3.4, Measure of Position and Outliers. In previous section, we talked about the mean and the median as ways to describe the center of the data, while variance and standard deviation were used to describe the spread. In this section, we are going to discuss precise ways to describe the relative position of a value within the entire set of the data. One way to do this is using z-scores. So they provide a way to compare variables with different centers and/or spreads. So z-scores at the end of the day represent the distance of a data value is from the mean in terms of how many standard deviations it is away from the data value. In other words, a z-score measures how many standard deviations the data value is above or below the mean. Here we have the precise formulas to find the z-score. Notice that the formulas are very similar. The only difference between the two will be the notation we use, whether we use a population or sample data. So to find the z-score, let's say of the population, we take the value of interest, subtract the population mean, then divide this difference by the population standard deviation. On the other hand, for the sample z-score, we take the value of interest, subtract the sample mean, and divide by the sample standard deviation. So at the end of the day, z-score has a general formula of we take the value of interest, or the observation of interest, subtract the mean, and divide by the standard deviation. Now z-scores do not have units, and if an x value is below the mean, then the z-score will be negative. If the data value is above the mean, then the z-score would be positive. And so we'll know if the data value is above or below the mean, whether the z-score is negative or positive. And we are going to be rounding z-scores to 2 decimal places. Let's look at an example. It says you are filling out an application for college. The application requests either your ACT score or your SAT-1 score. You scored a 26 on the ACT and a 650 on the SAT-1. On the ACT exam, the mean score is 21 with a standard deviation of 4, while the SAT-1 has a mean score of 514 with a standard deviation of 113. So which test score should you provide on your application and why? So at the end of the day, you would want to provide the one that is above the mean, right? And the further above the mean or the higher above the mean, the better. It means you did better than the average. But to know if the scores here are above the mean or which one is higher above the mean, we have to find the z-scores to be able to compare them because, as you can see, they're measured on different scales. Let's organize the information first. So for the ACT, we're given that the mean is 21 with a standard deviation of 4. And here your score was a 26. So that's going to be our x value. From the SAT, the average was 514 with a standard deviation of 113 and the score is 650. So let's illustrate what's going on here with a picture. So with the ACT, there's a number line. The mean is a 21 and the standard deviation is 4. So I'm going to go one standard deviation above. So I'm going to add 4. So the next number will be 25. And then one more would be 29. Our value of interest is 26. So 26 falls just a little bit above 25. So as we can see, our score of 26 is 1 and a little bit more standard deviations above the mean. Let's look at the SAT score. So the average is 514. One standard deviation of 113 would give us the next score of 627, and the following one of 740. So the score here of 650 will be above the 627, which is also a little bit more than one standard deviation above the mean. But exactly how far? Well, this is where we have to compute the z-scores. So the z-score for the ACT would be the value of 26 minus the mean of 21 divided by standard deviation of 4. And so this is going to give us 1.25. For the SAT, the z-score would be 650 minus 514 divided by the standard deviation of 113. And so we're going to get 1.20. So here are the corresponding z-scores. So as we can see, the ACT score of 26 is 1.5 standard deviations above the mean, whereas the SAT of 650 is only 1.20 standard deviations above the mean. So here the SAT score of 26 is farther above the mean, and therefore it's a better score. It tells you that you've done much better than the average student as opposed to the SAT. And so in this case, we would report the ACT score on the application because it has a higher z-score and tell us it is higher above the mean. Let's look at another example. It says a highly selective boarding school will only admit students who place at least 1.5 standard deviations above the mean on a standardized test that has a mean of 200 and a standard deviation of 26. What is a minimum score that an applicant must make on the test to be accepted? So let's see the information that we are given. It says here that the school would only admit students who place at least 1.5 standard deviations above the mean. We are given that the standardized test has a mean of 200 and a standard deviation of 26. So here the 200 would be the mean. So this would be our mu, whereas the standard deviation of 26 would be our sigma. And here the scores in terms of the mean and the standard deviation are given as the general result from the standardized test, and therefore we can assume that these are the parameters, the population mean and population standard deviation. Now the question asks for what is the minimum score that an applicant must make on the test in order to be accepted. So the value is asking for the score, which is the variable of interest. So it's asking us to find the x value when they give us a mean and they give us a standard deviation, and they give us another piece of information which says that whatever score we find has to be at least 1.5 standard deviations above the mean. Well, if you recall, by definition, a z-score tells you how many standard deviations a value is above or below the mean. So in this case, a 1.5 is referring to a z-score. So they give us a z-score, they give us a mean, they give us a standard deviation, and then asking us to find the x. And so the relationship that we have between all these four values is with the z-score formula. C equals the value minus the mean over the standard deviation. So we can plug in for the values that we have, in this case the z, the mean, the standard deviation, and solve for x. So if we plug in, we're going to have 1.5 for the z. X is the one we still don't know, minus the mean of 200 divided by the standard deviation of 26. So here we have an equation with one unknown, in this case the x score. So now to solve for x, we first multiply by 26, so we can cancel the 26 on the right hand side. What we do on one side, we have to do it on the other. So on the left hand side, 26 times 1.5 would give us 39. And on the right hand side, we still have x minus 200. So the next thing to do would be to add 200 to both sides so that we can isolate x. So then we have 239 equals x. So this means that the score has to be at least 239, right? That's going to be the minimum score. So the minimum score to be accepted should be 239. So any score of this or above, the student would be accepted into this boarding school. So this would be another application of using z-scores.